Welcome to today's ArXiv CS Digest for March 23, 2026. We received 687 new computer science papers today across 60 subfields. Let's dive into the top picks. Trend 1 of 5, computational complexity and control systems. This trend integrates computational complexity with control systems to analyze algorithmic efficiency and fundamental limits for control problems. This cluster covers 75 papers. Representative work includes flip distance of non-crossing spanning trees, NP hardness and improved bounds, a dividing line for structural kernelization of component order connectivity via distance to bounded path width, and semi-infinite programming for collision avoidance in optimal and model predictive control. Trend 2 of 5, advanced vision language model reasoning. This trend advances vision language models by enhancing their reasoning capabilities through architectural innovations, efficient training, and novel adaptation. This cluster covers 162 papers. Representative work includes end-to-end training for unified tokenization and latent denoising, think JEPA, empowering latent world models with large vision language reasoning model, and dual CoTVLA, visual linguistic chain of thought via parallel reasoning for vision language action models. Trend 3 of 5, AI system valuation and ethics. This trend unifies research on assessing AI system performance, capabilities, and their ethical and societal impacts. This cluster covers 133 papers. Representative work includes Atlas RAN, modeling and performance evaluation of open 5G platforms for ubiquitous wireless networks, the price of progress, price performance, and the future of AI, and greater accessibility can amplify discrimination in generative AI. Trend 4 of 5, multimodal video and 3D processing. Advancing AI to understand, generate, and process complex video and 3D data by integrating diverse modalities. This cluster covers 166 papers. Representative work includes World Cache, content-aware caching for accelerated video world models, Video Detective, clue hunting via both extrinsic query and intrinsic relevance for long video understanding, and Unimotion, a unified framework for motion text vision understanding and generation. Trend 5 of 5, optimizing diverse machine learning models. This trend advances diverse machine learning models by improving their performance, efficiency, and interpretability across various applications and domains. This cluster covers 151 papers. Representative work includes decoupling exploration and policy optimization, uncertainty-guided tree search for hard exploration, characterizing high-capacity Janus aminobenzene graphene anode for sodium-ion batteries with machine learning, and confidence-based decoding is provably efficient for diffusion language models. Up next, our first paper out of 5, Auditing Paper Token in Large Language Models by Ander Artola Velasco and Manuel Gomez Rodriguez from Max Planck Institute for Software Systems. Let's break down its key contributions. This paper introduces a novel auditing framework based on martingale theory, designed for trusted third-party auditors. It provides a robust mathematical foundation to detect token misreporting by LLM providers. The framework utilizes a sequential querying mechanism, allowing an auditor to incrementally gather evidence from a provider's reported outputs. This iterative process is key for efficient and timely detection of misreporting. A key contribution is the framework's guarantee to always detect token misreporting, regardless of the provider's policy. Crucially, it also ensures a high probability of not falsely flagging faithful providers. Up next, our second paper out of 5, Causal Evidence that Language Models Use Confidence to Drive Behavior by Darshan Kumaran and Viorica Petrosyan from Google DeepMind. Let's break down its key contributions. This phase establishes uncontaminated internal confidence estimates within LLMs by observing their responses without an abstention option. It provides a foundational measure of intrinsic model uncertainty for subsequent analysis. This phase reveals that LLMs apply implicit thresholds to their internal confidence estimates when deciding whether to answer or abstain. Confidence emerged as the dominant predictor of this behavioral regulation. This phase provides causal evidence by actively manipulating internal confidence signals through activation steering. Artificially boosting or suppressing confidence directly shifted abstention rates, confirming confidence's role in behavior. This phase demonstrates that LLMs can systematically vary their abstention policies based on explicitly instructed confidence thresholds. It shows models actively deploy internal confidence to implement adaptive behavioral strategies. Up next, our third paper out of 5, the color code, the surface code, and the transversal CNOT, NP hardness of minimum weight decoding by Ashojin Gu and Alexander Kubica from Yale Quantum Institute and Department of Applied Physics, Yale University. Let's break down its key contributions. This work establishes the computational intractability of minimum weight decoding for the color code when subjected to Pauli-Z errors. This highlights a fundamental challenge in efficient error correction for this specific quantum code. The paper further demonstrates the NP hardness of minimum weight decoding for the surface code under general Pauli X, Y, and Z errors. This extends the intractability result to a widely used and robust quantum error-correcting code. A third key finding proves NP hardness for the surface code when considering a transversal CNOT gate, Pauli-Z errors, and measurement bit flip errors. This addresses a practically relevant scenario involving logical circuit implementations. Up next, our fourth paper out of 5, Silicon Bureaucracy and AI Test-Oriented Education. Contamination Sensitivity and Score Confidence in LLM Benchmarks by Iliang Song and Shuilong Li from Institute of Artificial Intelligence, TeleAI, China Telecom. Let's break down its key contributions. This framework systematically evaluates how sensitive LLM benchmark scores are to data contamination and assesses the confidence in those scores. It aims to distinguish genuine generalization from exam-oriented competence. 29 words. A novel router worker setup is introduced to implement the audit, comparing a clean control baseline with systematically perturbed benchmark problems. This setup helps identify if models reactivate contamination-related memory. 30 words. Up next, our fifth paper out of 5. Optimal compilation of syndrome extraction circuits for general quantum LDPC codes by Kai Zhang and Jianxin Chen from Tsinghua University. Let's break down its key contributions. Proposes Auto Stabilizer Check, ASC, a universal compilation framework for generating depth-optimal syndrome extraction circuits for any QLDPC codes. This framework addresses the gap between theoretical code designs and practical circuit deployment. ASC leverages the sparsity of parity check matrices and exploits the commutativity of X and Z stabilizer measurement subroutines. This enables an efficient search for optimal compilation schemes, reducing overall circuit depth. ASC iteratively invokes an SMT solver to search for optimal compilation schemes. It returns a depth-optimal solution if found, or a near-optimal one in case of solver timeouts, ensuring high-quality circuit generation. ASC is integrated with an end-to-end evaluation framework that assesses different compilation settings under a circuit-level noise model. This integration demonstrates significant reductions in circuit depth and logical error rates.